Before we get into the new and exciting stuff for this section, I want to revisit the definition of what a limit is and use that to help us figure out a new way to think about limits and to find limits. So remember that our limit definition says the limit as x approaches c of f of x is equal to L if f of x gets close to L, and remember that f of x is really just another way to talk about our y value. So if our y value gets close to some number L as x gets close to c, so as x gets close to some number. So as x gets closer and closer to some particular number, and we're given that number, we want to know what is our y value doing? What is our y value getting closer and closer to? So we're going to use this definition to help us understand how to find limits using a table of values. So rather than have an equation that we can plug a number into or a graph that we can look at, here in these two examples, we just have a table of values. We're just given an x and a y value for some of these points. So all of these points appear on my graph. So for example, this first one, 2.9 comma negative 3.7. If I were to graph the function f of x, it would have to pass through this point, 2.9 comma negative 3.7. So this is just a bunch of different points that appear on my graph. So I'm going to use these to help me evaluate the limit as x approaches 3. So you can see on both sides of 3 here, I've got 2.9, 2.99, 2.999. These numbers are getting closer and closer to 3 because that's what the definition of a limit depends on. It says as x gets closer to some number, what is the y value doing? And then the same thing is true on the other side. We've got 3.1, 3.01, 3.001. And we need to think about both sides. Since we're doing a two-sided limit, we need to think about both the left-hand limit and the right-hand limit before we can draw any conclusions about the two-sided limit. Now, one other thing I'll point out before we hop in here is that the behavior at 3 here, it says it's undefined. Maybe the function is defined at 3, maybe it's not. We actually don't even need to know that information. Remember, when we're thinking about limits, we're just thinking about what happens close to 3 on either side. If we're talking about the value of the function at 3, that's a different story. But for limits, we just need to know what's happening close to 3. So, like I said earlier, we're doing a two-sided limit. Let's think about the left-hand side first. So I want to know the limit as x approaches 3 from the left-hand side of this function f of x. So here we say when x is 2.9, our y value is negative 3.7. When x is 2.99, our y value is negative 3.94. And when x is positive 2.999, our y value is negative 3.9982. So here I just want to ask myself, well, what y value are we getting closer and closer to? If I just look at those y values, what would you expect to see then at 3? And here I'm not trying to trick you or anything. We're just going to stick with whole numbers for right now. We would say our left-hand limit, it looks like each of those numbers is getting closer to negative 4. So that's one side. I got to think about the right-hand side too. So over there, we're going to say limit as x approaches 3 from the right of f of x. So, okay, here we've got when x is 3.1, we've got a y value of negative 4.2. When x is 3.01, we've got a y value of negative 4.05. And when x is 3.001, we have a y value of negative 4.0002. So again, it's really those y values that I'm looking at. Okay, what y value are we getting closer and closer to? What would you expect to see right here? Well, again, it looks like our y values there are getting closer and closer again to negative 4. So we've got the left-hand limit is negative 4, the right-hand limit is negative 4, and that means that the two-sided limit will also be negative 4 since they meet. Remember, if those two are different numbers, then we would say that this limit does not exist. So all we're doing here is we're saying as we move that x value closer and closer to it, we want to pay attention to the y values and see what we're getting closer and closer to there. Let's look at one more here. Here I've got another function g of x. Here we have as x is approaching -6. So for the left-hand side, I've got -6.1, -6.01, and -6.001. And then for the right-hand side, we start with -5.9, -5.99, and -5.999. So I'd recommend actually that you pause the video to try this out. Think about the left-hand limit and the right-hand limit. What y values are they approaching? And then see if we can draw a conclusion about the two-sided limit. So hopefully you've had a minute to try that out. Let's look at the left-hand limit first, and let's check our answers. So here, let's look at the left-hand limit as x approaches -6 from the left-hand side of our function g of x. If we look at our y values, here we've got 5.1, 5.03, 5.0004. Here, it sure looks like our y values are getting closer and closer to +5 here. But if I go over to the other side and I want to look at the limit as x approaches -6 from the right-hand side of g of x. So, okay, our y value here, we've got 7.2, 7.1, 7.0005. Here it looks like our y values are getting closer and closer to +7. So here in this instance, we've got the left-hand limit is 5, right-hand limit is 7. We said in these instances when these two numbers are different that our two-sided limit does not exist here.